road widening project involved construction of a new two-lane bridge across the Wanimbuka River on Kings Road, 9 miles from Suva, Fiji. An accredited manufacturer of pre-stressed structures for roads, Humes decided to set up and cast the 7 32-meter-long pretension post-tension I-beams on site beside the existing bridge. The bridge beam engineering design was performed by Humes' in-house team at Brisbane, Australia. The fabrication and assembly of the reinforcements for the structures was carried out by Humes Fiji at its manufacturing facility at Lami, Fiji. Once the complete set of reinforcement steel was completed for the first beam, the individual segments were trucked to the construction site. This is the steel formwork in which the concrete beams will be poured. The first step requires placing the individual sections of the reinforcement steel sections into the formwork. Here is a section of reinforcement steel setting inside the formwork. The fitting of the rebar sections and the connection of all sections into one welded structural unit requires considerable effort before the entire structure can be positioned in the formwork for pouring. Pouring the formwork is a very critical step in the manufacture of high-quality beams, and Humes supervisors are especially hands-on in this phase of construction. Portable vibrators are used extensively to ensure even distribution of the concrete to achieve good compaction, resulting in highly durable, strong products. Each beam requires 35 tons of concrete, 5 tons of high tensile steel, and 2 tons of pre-stressing steel cables. Here, an electric converter unit drives external form vibrators mounted along the side of the formwork. The poured beam is allowed to gain transfer strength for 2 days and then lifted out of the formwork so the remaining 6 beams can be produced as per casting program. First, the gantries must be removed before the beam can be lifted. This massive beam, 32 meters and 40 tons, requires 4 cranes operating together to lift safely. Lifting the beam with 4 cranes operating as a unit requires expert teamwork and close coordination and must be directed by an experienced Humes lift master. Safety is a very important issue in a multi-crane operation such as this, and extreme care must be taken at all times. One down, 6 to go. The next step in constructing this steel reinforced beam requires pulling steel cables through the conduit running the length of the beam and then stressing the cables with a hydraulic stressing jack to a predetermined jacking force. The stress cables are anchored at each end of the beam with anchor blocks. End caps are fitted so the grouting cement can be pumped into the ducting containing the steel cables through the injecting nozzle fitted with high pressure hoses. After hardening, the cement grout will permanently anchor the stress cables to help ensure structural integrity of the beam under its design workload. Due to traffic considerations, the fitting of the beams to their bridge foundations was scheduled at night. After the first beam had been lifted onto the 2 opposing trucks, the trucks drove the beam into position on the existing bridge. Multiple cranes were again required. After the cranes are connected and the beams lifted, the trucks are driven away. Extreme care, coordination and teamwork are required to finally place the first beam onto its foundation. One down, 6 to go. Humes completed placement of the Wainupuku Bridge beams on schedule and on budget in April 2011. Humes Industries, the leader in Fiji for quality concrete-related construction for more than 50 years.